Welcome. In this video, we're going to talk about adding integers. I'm going to introduce a few concepts here, and then we'll have other videos where we do practice problems. It's important to remember that in mathematics, on a number line, negative numbers all the way to 0 and then all the way to positive infinity. So from negative infinity to positive infinity. So if you start out with negative numbers, you get to 0, and then you go on to the positive numbers. These are integers. You have already worked a lot with positive numbers, especially adding them, subtracting them. So you have things like 5 plus 2 or 5 minus 2. So those are very common in mathematics. Like these are very common to begin the process of learning the concepts in mathematics. But what happens when you start dealing with negative numbers being added to positive, or negative numbers being added to negative numbers? These are some of the things we'll be discussing in this chapter. One of the things that you learn on page 113 in the book, the pre-algebra book from Redwoods, is about vectors. A vector is a mathematical object that possesses two important qualities: magnitude and direction. So the opposite, or the other thing you might hear about in math or physics, is scalars. And we're not going to go into details in this right now, but what we're just going to say is that a vector is something that has a magnitude, right? The other word we can use for magnitude or length, you learn in your book, magnitude and direction. So think of it this way. There are some things that when you describe can only have a positive value. They cannot have a negative value. That's another way to think about some of this. Or even some things like speed, for example, is usually called a scalar quantity, and velocity is called a vector quantity. So velocity gives you magnitude and direction. So in this section from 2.2 of the textbook, it talks about adding integers. And so they talk about vectors on a number line. They give you examples of what that looks like, with the number line. So on a number line, you could have a situation where, this is 0, and they gave you that example of going to 4, and they say that is a vector representing positive 4. So vectors are discussed in the beginning of this section. They go on to talk about absolute value also in this part of the section. Now remember, when you talk about the absolute value of something, it usually then gives you the positive value of that number, or how far that number is from 0 on the number line. So they talk about absolute value, and that's a very important concept. And so when we add integers, one thing we can keep in mind is we can use a number line to try and show the addition of integers, right? So for example, if you have a number line here, and you have from 0 to 3, and then from 3 to 8, and if I asked you what is 3 plus 5, for example, well, you know from here to here is 3, and we know that from here to there, right, is 5 units from this one. And so basically 3 plus 5 is 8. We know that, and we can kind of show that too. There's another way if you want to, you could try and show it, but we know this to this is 3. We know that to that is 5, right? That wouldn't help us as much here, but if you were to take this value here, you could essentially put it over here, and it will take you to the number 8. But using a number line to add numbers is something that you might not be doing every day, and that's fine. But in this section, you're going to be using the skill just to practice, to make sure you understand how the number line works. And so adding integers, if you're just adding them, things like 5 plus 7, you just use the knowledge you learned before. You add those numbers together. 25 plus 24, you add it like that, you get 49. But what happens when you have a situation like negative 7 plus negative 4? Well, first of all, in mathematics, something that is important to note is when you have two signs back to back, you need to allow them to have an interaction to produce the one sign that wins in that case. And remember, a positive times a positive is a positive times a negative is a negative times a positive is a negative. Now I'm using a dot here to represent multiplication, and that is common. Instead of writing it out as plus times plus, it's helpful sometimes to just write a dot in between two things. And a negative times a negative is a positive. So in this case, where we have negative 7 plus negative 4, this actually becomes negative 7 minus 4, which is negative 11. So notice that it's negative 7 minus 4, which becomes negative 11. So you've taken two negative numbers, they come together, and they will give you a negative value, right? Think of it this way. If you owed $7 for something, and then you went back to the same store. So let's say they told you, hey, just pay us later. And so you're going to pay them later. Maybe you forgot your wallet at home. So you have $7, even though these days you can use your phone to pay for things. But let's say you forgot your wallet and your phone. So you have $7 you owe the store, right? So that's technically like a negative $7 to you. But then imagine if you go back the next day and you're like, oh no, I forgot my wallet again. And let's say they gave you something for $4. So now you owe them $11. So notice that the negative is tied more to owing somebody something. And that's what what happens when negative 7 and a negative 4 meet and they're adding together. They give you a negative number. So that is part of how we add integers of this kind of situation. Let's quickly recap the different situations. So we have situations where we have 7 plus 3, and that's just 10. We have situations where we have negative 7 plus negative 3. That becomes negative 7 minus 3, which becomes negative 10. So it's something to keep in mind. If we have a situation like negative 9 plus 4, now we have a unique situation where we have a negative 9 here and we're adding 4 to it. So remember, because you started with the negative, that of the number that is bigger by itself, but that has a negative in front of it, your final answer you should expect would have a negative. So negative 9 plus 4 is actually negative 5. Imagine the situation happened where you owed $9 and then you came back and you paid $4. You would still owe $5. So try and use real life situations to make sense of any math problems that you're trying to think through, especially with these types of problems. Try and attach it to something that will be helpful for you to understand. So those are some examples of adding integers. So there are situations where you can add integers with like signs, and there are situations where you can add integers with unlike signs, kind of like this one that we just did. They have unlike signs and we're adding them, and that's what we get. When you have negative 9 plus 4, because this is a bigger number by itself, and you're adding 4 to it, you end up with negative 5. So let's look at a few things here before we wrap up this video. We have situations where if you have like 5 plus negative 9, then remember one of these signs will win. You can't have two signs at the end of the day. So it becomes 5 minus 9, and that's because a positive times a negative is a negative. So 5 minus 9, which will be equal to negative 4. One of the things that is helpful in understanding the section here before us is the commutative property of addition. So let's look at the commutative property of addition. So in the commutative property of addition, you have a situation like x plus y is equal to y plus x. So the commutative property of addition, again, the idea is that you can move things around. That is allowed in mathematics. The commutative property of addition. When two things are adding, you can move them around. So 3 plus 2 is equal to 2 plus 3, right? Whether the 3 is the first term or the second term, as is in the case on the right side of the equation, the answer is going to be the same. The left side and the right side will be equal. So 3 plus 2 is equal to 2 plus 3. That's one way to think about this. The commutative property of addition. Now note that there is also a commutative property of multiplication that you will see over and over. And that is the same scenario. 3 times 2 is equal to 2 times 3. 3 times 2 is 6. 2 times 3 is 6. And in math, when you use the word equal, it literally means the thing on the left side is equal to the thing on the right side. That's very important to note. So that is the commutative property of multiplication. Before we continue, or before we look at other things, let us also talk about the associative property of addition. So the associative property of addition. So make sure you take good notes. If you have any questions about taking notes, let me know. But make sure you just, even if you have to print out some of these properties, which they are included in the Tools for Master Mathematics book that we provide to you, but just make sure that you have good notes explaining the things that you've learned. So the associative property of addition basically says that if you have two things adding, right, in this case in a parentheses, these two things are adding and it's equal to these two things being grouped together, adding as well. So you can add the two terms first before you add the third term, or you can add the last two terms at the end before adding it to the first term. That is completely fine. That's the associative property of addition. And that principle also applies with multiplication. If you add A times B times C and the A, B are multiplying together, it would equal A times B times C if the B, C are, because remember with your PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, right? So you start with parentheses and then exponents, multiplication, division from left to right, addition, subtraction from left to right. So it's important that you recognize that the associative property of addition and multiplication are helpful in simplifying math problems. That's part of why we teach those concepts. And your book does describe or discuss that in this section. They also discuss the additive identity property and the additive inverse property. The identity property, when you think of the identity property, think of the idea of something adding to 0, right? They use A plus 0 is equal to A. 5 plus 0 will be equal to 5. It looks like itself, right? It is itself, the identity property. And then the inverse property is where you take a number, for example, and you add the opposite of the number to that number, and you will end up with 0. So the additive inverse talks about bringing a number from whatever it is to 0, and that's very important. So there are times in math where you want to group things together and then simplify those things that you group together first. And that's where the commutative property, the associative property, and so on can be very helpful. This is what chapter 2 deals with, is learning how to work through, adding integers and understanding the commutative property and so on and so forth. If you have any questions about this, please do not hesitate to send an email or a message, and I can provide more explanations. In the exercises at the end of the chapter, you'll be focused more on the, the computational problems, which go all the way to number 79. But you're just practicing, you're using your skills, showing the additive inverse, showing the different properties that are being used, whether it's the commutative property or the associative property. And remember, with the associative property, you have a parenthesis that you're typically dealing with, and that's very important to note. If you have any questions, please let me know. Otherwise, have a wonderful day.